In this recording, we're going to explore a game of life simulator. So, game of life is cellular automata, which has very simple rules. Basically, each cell counts the number of live neighbors, and if it's within a certain range, then that cell either becomes alive or it dies. So in this simulation, we have some preset patterns, such as we have a glider creator, which is called the Gosper gun, and basically it continuously creates these gliders. And we can slow down the simulation a little bit, and you can see the gliders always follow a diagonal path, and they can interact with other patterns. So in this recording, we're going to explore a specific pattern called the Metacell, which is essentially a pattern which allows game of life to simulate itself. So let's see. So this is a glider eater pattern. This is an AND gate, OR gate. This is a reflector. This is just for, it's not a pattern, this is just for comments, like showing the paths of the gliders. Here's another glider simulator, or glider generator, which only creates a glider every 30 steps. Here's another reflector. Okay, so here we go. So this is the Metacell. So in this video, we're going to tile a couple metacells and explore how they evolve. So let's start with one. And then let's add another one. So Game of Life has been a passion of mine for many years, and I have written simulations in the past, but perhaps not as efficient. So this simulation uses the shader language, high-level shader language. So we're running these on the GPU. That's why it's relatively fast, given the size of the grid. There are other methods for simulating game of life, such as hash life, which basically uses a quad tree approach, and it looks at a small grid, and it saves the patterns that it has seen, and it looks for periodicity, because game of life is very periodic. So you see all these patterns here. They have a period of 30 or 60, and essentially the hash life algorithm, it memorizes these patterns and it stores them in a hash table. And then when it sees that pattern again, instead of simulating every single pixel, it just looks up the pattern and sees what step it's in. what phase it's in. So this simulation does not implement hash life algorithm, but I'm considering giving it a try. Okay, let's see. Okay, so you see these patterns here on the sides. They have to match up. That's how you know the tiles are properly aligned. Okay, so create this one. Let's create some more. So we're going to create 16 of these. It's a 4x4 grid. Yeah, it's a little sluggish because the grid size is very large. Each Metacell is 2048, I believe. So if you multiply that by 4, that's well over 8,000 pixels by 8,000 pixels, something like that. Okay, let's see if we align this here. Okay. Let's do another one. Yeah, I do need to think of some way of maybe speeding up the dragging process. Dragging these patterns around because it's currently really sluggish. Okay, let's see. 25% done, almost. Okay, let's align these. Oh, it's already aligned. Okay, great. Okay. So I will let you guess what the initial pattern for the overall simulation is going to be. Oh, there you go, aligned. Okay. Let's do another one. I'm just wondering, how can I implement hash life and have it utilize the GPU? because this utilizes the GPU, and as you can see, is much faster. So I'll have to think about that. Because the issue with using the GPU is that you don't want to transfer too much data from your RAM into the GPU memory, because that's the most expensive part. So if you have a huge hash table of different patterns, then how would I don't know. Well, I'll think about it. Okay, so it's aligned. So this cell is going to be alive. So this is what it looks like. Okay, create this one. Let's create another one. Okay, we're almost done. Almost halfway. Okay, create this one. Okay, and now I think it should be obvious what the initial pattern is that I'm making, but I'll let you think about it. Okay. Okay, these are aligned. Okay, one more. Okay, and this one is going to be off. Okay, create this one. Okay. Okay. And this one is going to be on. Okay, create this one. And this one should be off. Okay, created. Create this one. Okay, well, at this point, I think it's really obvious what the initial pattern is. Essentially, it's going to be a glider. So we're going to see how the glider simulates on this larger grid. Okay, create this one and last cell. Okay, and this one should be alive. So create this one. Okay, there you go. So the initial pattern is the glider. Okay, so let's zoom in. See what's going on. So Game of Life has a few patterns which move in a specific direction. And the glider, this one, always moves diagonally, but there are other patterns which move vertically and horizontally. So these are the spaceship patterns, I believe they're called. Okay, so this structure here, it helps the algorithm figure out whether it's next to an edge. So as you can see here, these guys disappeared because they're internal. But if we look, well, I thought, I don't know, maybe I messed up somewhere. But basically, for the edge cells, these patterns are supposed to prevent the cell from counting the non-existent neighbors, right? So essentially each cell counts the number of alive neighbors, and depending on that number, it either becomes alive or dead for the next step. So this here is actually the logic section. So as you can see, there are three, 1, 2, 3. So these three are the three possible states where the cell can be alive. So there are 8 possible, okay, 8 neighbors, right? So you can have 0 to 8, which is 9 possible counts, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, where all of them are alive, right? So these are the different states. Okay, so let's see, so this is a counter. You see each time it moves by 1. So when this counter reaches 0, then the cell changes. But it needs some time in order to go around. So let's see, there should be a spaceship that's just going around and counting the neighbors. See, is this the... Okay, so this is the timer, and then... Oh, there we go. It's either this one or maybe it's this one. I'm not sure. Okay, so let's just follow this. It's basically, I believe, these have a similar structure as these guys. Yeah, there's a whole zoo of different spaceships and reflectors and spaceship generators and such. You can even have logic gates, and you can even have a computer, like a fully functional computer. Okay, well this is really exciting. Let's see, I believe, where does it do the count? So these guys, so okay, so these are both alive, right? So this is the pattern. Let's check here. This one's alive, this one's not. Okay, is it the same pattern here? Okay, where's the edge? Okay, this should be the edge here. Ah, I think this little dot here. So let's see, is there... I'm not sure. Let's see what's the difference here. Oh, yeah, it is this dot, right? So in this case, it moved, right? Let me see. Yeah, so here. Okay. Is my microphone working? Let's see. Should be. Okay, so here's the counter from this side. Okay, so we haven't changed yet. We're still in the initial configuration. So we're still counting the neighbors. Let's see. There must be a way to count the neighbors. Oh, okay. So we have 1, 2, 3, 4, 5. So what does that mean? So this cell has 1, 2, 3, 4. I guess it has 5 live neighbors, including itself, right? So let's see, it's 5. Okay, so now it's gonna go in here. And I believe this just transforms it. It just transforms the type of spaceship. Okay. Okay, so we set the states here. And so there should be another spaceship that comes along and reaches the state. Okay, so here's one going here. Okay. And I think there should be another one that reached this state. Oh, okay, so here. Okay, so technically the countdown is still going. You see the countdown is still, okay. Okay, here. So finally, we have a signal from our clock, and now it's going to go, okay. So it transformed into a different spaceship. Let's see what else is going on. So we have this spaceship here, and then I think that's all that's going on. No? Let me see, where's this guy gonna go? Oh, okay, so it created these two gliders and then, oh, three gliders. Okay. Where did it go? Did I miss it? No, it's this guy here. Okay. Okay, I believe. Let's see what's going to happen to this cell. I believe. Um, it has too many neighbors, right? Okay, so we have two spaceships, one going here. Let's just follow this guy for now. I think what's going to happen is it's going to turn off this stream going this way, and then this guy is going to turn off this stream going this way. So let's see. Okay. Okay, so now we don't have those spaceships here, right? So they get annihilated. So that means that this cell becomes dead, right? And this one becomes alive. This one and this one. Okay, well there you go. Oh, also this one. Is that right? Yeah, so this is the next stage of the glider pattern. So we have this one's alive and then these three are alive. Okay, once again we have the countdown. Where does the state for the neighbor, where's that stored? I'm not sure. It's not these guys. I think these guys, they just transform the type of spaceship. Maybe it's this little guy here. Okay, well, let's see. So this guy changed. So what changed? Yeah, I think this changed, right? What else changed? So this guy got moved a little bit. Okay, this guy also moved. I think these are the states for the neighbors. Okay, so now we have the 9. So originally it's 9. Okay, let's follow this. So originally it's 9. Then we know that, okay, 1 got destroyed. So this neighbor is alive, I think. We just counted it. This neighbor is not alive. So I think it's going to fail to hit this block here. So let's see. It's really amazing how these very simple rules can produce something that they can do this, right? Like calculate states and communicate. So these are like the particles, right? So if the universe, oh, okay, so here we go. So we missed this guy here. So this is this neighbor. So we're still at 8. So we're going to miss this guy as well. So if the universe was a emergent kind of a system that was a result of very simple rules, you could still have all the complexity that we see in the universe today. I think ultimately this is how the universe works. It's just a very, very simple finite automata. Okay, so we missed this this little diamond. I think that's called a diamond pattern. Okay, so we know this guy is not alive either, so we're gonna miss it. Okay, so we missed it. We're still at 8. And then this guy is alive, so I think. Oh, sorry. Yeah, so we missed this diamond here as well. And then we are going to hit this one though, because this neighbor is alive. Okay, so it annihilated 1. And so now we're at 7. Let's see. this guy is also alive. So we are, we're going to lose another one. Okay, so what's going to happen to this cell? Um, it has 3 neighbors. I think it'll be fine, right? Alright, I'm not sure. Okay, so here's our 6. Okay, so now we're getting back to the logic section. Okay. Okay, so nothing was set. So what does that mean? I think that means this cell is going to be fine, right? I will be watching this cell because it has only one neighbor. So that means it's not gonna it's gonna change its state. Okay, so anytime now we're gonna see these 2 spaceships that turn off the spaceship generator here. I just don't see it yet. Oh, maybe it's this guy here. Okay. Okay, so these are the two. Let's follow this guy this time. Okay, so here we see this little dot here. So that's going to disappear. And that's going to turn off this spaceship generator. Okay. Okay, there we go. So this cell is not alive anymore. Let's see what else changed. This cell is not either. But this one is. This is the new alive cell, and these two are unchanged. Okay, well, there you go. I could basically watch this all day. Okay, so there we go. Yeah, this is a little sluggish. Maybe I should look into the hash life algorithm. There is a tool called Golly, and I'll share a link. And that does have all these fancy algorithms implemented, such as hash life and others. And you can look at the different examples they have there. In fact, these metacells are from there, so you can export the different patterns as an image, and basically this program just reads an image. Oh, okay. So here's the generator for our 9 spaceships that go around. Okay, well, there you go. Let's see, let's do a final. Okay, so there, good screenshot, or good thumbnail, right? Okay.